d 2 power ex two e power x plus 2 e power negative x is equal to 5. So we are still solving for x. Now we know that whenever we have x power negative 1, it's the same as we have 1 over x. Okay, so we never like dealing with negatives. So what we'll do is we'll write this as 2 ex plus 2 over ex is equal to 5. Again, we don't want ex to be in the denominator, so multiply throughout by ex so that we have 2 ex multiplied by ex plus 2 is equal to 5 ex. Like that. How many can't hear me?
Can hear you, sir.
Can you?
Loud and
We
clear.
can hear you, sir.
Very, very loud.
Okay,
You're
good.
loud, sir.
Thank you. So some people's network that is like using, so 2 ex, so ex times ex, we get ex squared. And then we bring the 5 to the left, and then plus 2 is equal to 0. So at this point again, we let y to be ex, so that we do with 2y squared minus 5y plus 2 is equal to 0. Next, we'll have 2 by 2 as a product, so that it becomes easy. Here we can use -1 and -4 as our factors. And then we have y, so that 2y minus 1. We also have -2, so we get 2y minus 1 is 0. So y is equal to 2 and y is equal to 1 over 2. So we have these two, so that we now go back to what y is. So what is y? Y is ex, so we're saying ex is equal to 2. Here the natural log will make a lot of sense because x will just be in 2. Also, ex is equal to half, giving us the natural log of ex to be the natural log of 2 to the power -1. So x is negative natural log of 2. So these are solutions. So don't forget the property that says if I have this here, the same thing is there, automatically I get 1. The same goes for log e. E, it will be 1, but e is lean. So that's why we say log e is 1. So keep the properties.
Sir,
Hello.
So when you get the natural a fraction, when you introduce a natural log to a fraction, you always get a negative. That is the rule.
If you don't write that a fraction, because this thing I've
Or you
written
can,
here, this thing I've written here is the same as
or, or
x in half.
okay.
But then it then just look nice. That's why I've written it as negative in 2.
But it's okay if even if you write it 1/2, right?
Very much okay.
Okay.
Okay. So we go to question 3. Question 3.1.
Slide back. Screenshot. Right.
Log 3 is equal to 3x minus 2. Then we to see what else we're going. So minus 2 log x3 is equal 1. So when the point is log, and this is different. It's simple. Let's make the basis the same. Apply change of this mirror. Log from log a x log b will be x over log b. Where you know some people you know this. I say numbers in the second. Very good. So change the base from x to 3. So we have log 3x minus 2 log 3 over log 3x is equal to 1. Change the base to what? N. At point now we can plot by log 3x. So I have log 3x by itself, that is 2. 1 is equal to 3x. Because the denominator here, this always cancel with that when you multiply. And this part is by this, by that. Okay. Then we now have some things to help.
Now, how did you just make negative? Like the 3x of the impact.
Because we set log a is 1.
Right, right. Thank you.
Can we take it aside? So have log 3x squared minus log 3x minus 2 is equal to 0. And then let's save us, let y be log 3x. So that we have y squared minus y minus 2 is equal to 0. Become a quadratic. So when do you think of a quadratic? We have one part squared, the other not squared. It's a constant of. Then you know this is a quadratic. Then it will be the best. So if I got this, hello?
So I need to clear on how you came how that get.
So it's the same from here. So log 3 is 1. So this is becoming y squared plus y minus 2y minus 2 is 0. This is y plus 1 minus 2 y plus 1 is 0. So we get y plus 1 y minus 2 is 0. So y is equal to 4, y is equal to 2. Now let's go back log. Now what is the y? So the first thing is log 3x is equal to -1. This y is equal to -1. So there's a part where we said if you have the property we said that if you have log a b is equal to 1 b, so that we use it here. So this is the 3 power -1 is equal to x, giving us x is equal to 1 over 3. We come back to the other one. Log 3x is equal to 2 when 1 is equal to 2. So that again, this will mean 3 power 2 is equal to x, so that x is equal to 9. Another value of x. Coming from the same property. We have question here.
Some question.
Yes.
Let's example. You want to change that log this the two log 3 and base x. You want to change this to base 3, and then you change log 3 to x. How is going to because yeah, I don't know if that's this. Yeah, so you just get you got a specific area you get.
It doesn't matter.
Doesn't matter.
No. It will come out.
Or it comes out.
Yes. So what you have when you read here, you'll be having like log x, and then because these numbers can still come out. So let's see, log x3 is equal to -1. Let's see if that is making sense. X -1 is equal to 3. So 1 of x is equal to 3. So equals multiply and equal to 3x. So x is 1. So it's still, you still get the same answer.
Okay.
So no. But then it starts changing to constant. But with further simplifications. These are easy because they are no numbers. Okay, so let's move to this was 23(1). This was 23(2). Plus 2. We have log 3. 2 minus 3x plus 9. 6x minus 19x plus 2. So again, we have mixed here. But one thing I know is that log ax is equal to log ay. This will be there as log ax minus log ay, which is equal to 0. And subtraction system x over y is equal to 0. And we take it as 0, given x over y. So this is 1 is equal to x over y. It will like that 1 is equal to x. So I was just trying to show that whenever we have log a, whatever is here is equal to log a. Something else is here. These things are the same since the bases are the same. So from that, when we get back to this question, it seems that it's here. Same, but you are saying we have just got to the inside. So 2 is with log 3 here. 9 to log, and we change to 3, so that we get x squared minus 9x plus 2 over log 3. Now 9 there is 3 squared. Okay, so that we get 3 2 minus 3x is equal to log 3 6x squared minus 9x plus 2 over 2 paper down, then log 3 is just going to be 1. If we cross multiply, what we have is 2 log 3 2 minus 3x is equal to 3 6x squared minus 9x. The good news is since we said log a dx is the same as x log ab, it should be the same if you find x down and you have log b, you tell it is b x. So that we take 2 as power, so we have log 3 2 minus 3x squared is equal to log 3 6x squared minus 9x plus 2. So we now have the base. We have base 3, we have base 3. So this means that the inside things should be the same. So 2 minus 3x squared should be the same as 6x squared minus 19x plus 2. Mazuzo.
Can I be lost on the stage number 2? What did that number 2 come about?
So since the power of 3, we are able to drop it down using this property here. When you drop it down, you remain with log 3 and emphasize that whenever the base here is the same as this number here, what you get is 1. So asking log 3 will give us a 1 because the 2 at that time should be down.
Sir,
hello.
I think the part I am behind, of which image could be built as well, is this part here. When log 3, where you came up with this denominator log 3 base 3 to the power 2.
So what is 9? 9 is just 3 squared. So anywhere you found 3 squared, you have 9. So if you can do a reverse where we see 9 right at 3 squared, we are doing that because I've seen that 3 there is the best. So we know if we make the best the same as the inside part there, we are going to have a 1. So we force it to be 3 there. That's how come we are saying first thing we've changed the base from 9 to base 3. Okay, so down here, I'm supposed to have 9. Okay, but then 9 is the same as 3 squared. So I'll put 3 squared. But if I have log 3 squared, this is the same as 2 log 3. But this piece here is 1, so I'll get 2. That's how come I only have 2 on it.
Huh.
Hello?
How the 2 is indeed going to be 1 to the power 2 there because the 2 here is a power. So how is it becoming a 2 there?
How is it becoming a 2?
Instead of the 1.
2 is a power there, is it? And
Yes, sir.
what does log do to the powers?
I don't know.
You need to know.
Motive.
Log, look, I have log A, B, power x. If x is my power, the log will bring down that power and leave me with only that power.
Okay, we are together now. I'm happy.
Good. So that after coming up with this here, difficult to teach because you know a lot of things. We've done binomial, so expanding power 2, that's an easy thing. Then we take everything to the left. So we have 9x squared minus 6x squared. We have 3x squared. Negative 12x plus 19. We have plus 5x. And then 4 minus 2. We have plus 2 is equal to 0. The product is. Oh, it's not 5, it's 7, is it? Good. So instead of 5, it's supposed to be 7 here. Yeah, good. 19 minus 12 is 7. Then now the factor, so we have a product 6, the sum 7. So the factor should be, the factor should be 6 and 1. So plus 6x plus x plus 2 is 0. Factor out 3x. We have x plus 2. Factor out 1. We have x plus 2. Then x plus 2. Then 3x plus 1. So that x plus 2 is 0 or 3x plus 1 is 0. So that x is negative 2 or x is negative 1 over 3. There's no taking to any other equation because we did not let anything be whatever. We are just solving everything until we get here. Now, this homework must be done with you alone in the exam. So you can only easily do this if you've done enough practice. You've seen that in one question, you need so many properties for you to get to the solution. So Ghana going to be a good idea. Understanding is a good idea.
Sir, I have a question.
Uh-huh.
From the start, what if we took the log 9, that expression, to the left hand side?
Uh-huh.
And then we remained with a 0. So later on, would end up dividing the two expressions. The 4 minus 12x divided by that expression. Now the answer is
the division is only done if the powers are the same, is it?
yes.
Okay.
After checking everything, okay, let's go to 1, 2, 3, 4, 5, stage 5.
1, 2, 3, 4, 5. Okay, here.
And then we take the expression on the right to take the left, and then remain with the 0 on the other side. Divide the two equations.
Very good. Answer the same.
Yeah.
We do 2 minus 3x squared. You divide by what? X plus 2. And you 3 plus 0. You get 1. You're getting 1. Then cross multiply, so it's back. Is that
The answer will be the same.
So one have log 3 on the before the x, then we write log 3 over that. And that will the log 3 go. Yes.
Now we have said that whenever you have an expression log a b is equal to y, this is the same as a y is equal to b. That's how you take away the log.
All right. Thank you.
So what we say I said probably basic and log and base 9. So can we just go this way and then the two will be multiplied in there so that you get log 3 and log base and log base, so you cancel them out and then maybe 2 minus 3x equals to, then you multiply 2 throughout the quadratic that is in the bracket there. So now if
You don't at that point, if it's a question, then they're not, they become equal when they become the, there's nothing outside the log.
I'm going to say,
So when the bases be and everything else is inside, then the logs cancel.
oh,
So I'm going to remain this question. Remain is question 5. Because 3 part 2 in 3 part 3, that's the same as what I'm from doing. Okay, for question 2, yes?
That part is minus bracket square. Since this side is the quantification, another side is quantification. What you don't like about the same. Can you what my
I think I only got that. I don't got that is the same. So they're not going.
for saying that is 2 minus 3x like it's square. Since it is that equation is square, what it is you don't like them just with these separate
We don't solve it.
what
You don't solve that. This is the equation. You can't apply some power is this same by the solve it. I think somewhere. How do you
okay.
Looks like what I'm getting about, let's say x minus a is equal to x minus d. Then we get those. That's why we and then solve one quadratic. Okay, we are now
Sir,
logged out. Yes.
I'm asking for the previous. I just want to compare that.
So we'll be logging out and they have this is 11:20, 10 minutes break. At 11:30, we come back. So no one will remind you.
Sir.
Me, I'm not in any group. So at 11:30, I'll just open here and start.
10 hours break, sir.
10 minutes break.
Okay.
All right.
How is supposed to tell me?
Yeah, same.
Yes, I think.
Yeah.
3 hours math at 2 hours.
We won't reach 12. We just remain with one question. So when we come back at 11:30, before 50 will be done.
All right.
Okay.